Hi. So in this video, I will show you how to perform convection analysis in Ansys software. So here I am taking the fins for the convection analysis. So the temperature distribution on fins. So we have to going to find out the temperature distribution which is developed on the fringe surface. Right. So here the problem is the bottom surface of the fin is exposed to the heat flux of Q 1000 watts per meter, and the airflow over the developed surface keeping the surrounding temperature at 293 Kelvin. Heat transfer coefficient between the fin and the surrounding is H, which is equal to 40 watts per meter square Kelvin, and Kx is equal to, that is a conductivity, thermal conductivity is equal to 170 watts per meter Kelvin, and assume 50 mm thickness. Right, the fin is 50 mm thickness. Determine the temperature distribution within the developed surface. So we have to solve using the answers. So for that I am using the preference of a thermal, and select the element. We have to select the element as a solid element which is plane 55, and in the option we need to select the K3 of a plane thickness, then only the thickness value will be entered. Plane real constant, that is called as a thickness value enter for the element. So here the thickness is 50 mm. So we will enter the 50 mm, right? And in the material property we have to enter the thermal conductivity, that is called as a Kxx in the isotropy. So what is the thermal conductivity in this for this problem is 170 watts per meter Kelvin. So 170, ஓகே கொடுத்துக்கலாம், இதை க்ளோஸ் பண்ணிட்டு and draw the model. So I am going to use key point and area. So I will just enter the key point in the current coordinate system. So key point number 1 at 0 0, and the key point number 2. So I am taking this key point as the 2, that is the last one. The total value is 125. Key point number 2, x direction 125, and the key point number 3. In key point number 3 I am selecting this point is the key point number 2. So for that this point will be the key point number 3. For that I am taking, this is the x direction, this is the y direction, this is 125, this is 50. 125 50. Click apply, you will get the key point number 3, and the key point number 4 will be this point. Here it is 75, and y will be 50. 75 50, the point number 4. Click apply, and the point number 5 will be this point, at this point. So the height of this point is 25, and the distance is 75. So that is 75 comma 25. Point number 5, 75 comma 25. Click apply. So you will get the 5th point here, and 6th point. And the 6th point, I am taking the 6th point as this point, right? That is 50 comma 25. 6th point 50 comma 25. So we got the 6th point, and the 7th point. 7th point is this point, 50 comma 50. Seventh point is also applied. On the eighth key point is this point. This point is x is 0, y is 50. X is 0, y is 50. So eighth key point is applied, and ninth key point not required. So this is enough. So now I am going to convert this key point into area. How to convert this key point into area means just select the area, uh, click the arbitrary through key point. So first point, second point, third point, fourth point, fifth point, sixth point, seventh point, eighth point. Then click OK. You will get a area. This is one more method. You also create a area by using a rectangle, arbitrary by dimension, and drawing this full rectangle, and draw another simple rectangle at this point and cut this rectangle, right? That is also a method. And now the meshing section. So after creating the dimension, meshing section, so click the mesh tool and use the area set, and click OK and enter the value is 1 and click mesh, and you will get a very fine mesh, right? Now click plot control style says inside, and display of element for getting the thickness value. So you will get a 3D structure, that is the thickness of the fin is also added, right? Now apply the boundary condition and thermal values. So click the analysis. It is a steady state analysis, and apply the load value. Click thermal, define load, apply thermal, and heat flux. So in the question they have specified the heat flux at the bottom. The bottom of the surface is exposed to heat flux on line. So just click the less line, and you will get the heat flux, and you have to enter the heat flux value, that is 1000. So heat flux is applied at here, and convection we have to apply. So why the convection is applied means, in the question they have clearly explained that the air flows over the surface, keeping the surrounding temperature at 293, right? So that means because of the air flow, the convection takes place between the fins and the air, right? So the convection has to be given with help of the following parameters. So one is the surface temperature 293. Another one is the fin coefficient, that is heat transfer coefficient of the fin between the fin and the surrounding atmosphere is 40 watts per meter square Kelvin. Click convection on line. So where are the points mean, where are the lines which we are going to give this convection, that is this line, this line, this line, this line, this line, this line, and this line. So these lines are contact with the surface of the air. So the film coefficient, that is what the heat transfer coefficient, that is 40 bulk temperature is 293. Just enter and solve the problem. So just click solve current load step. OK. So solution is done. Now we have to plot the result. That is a thermal flux. Flux is some vector. This is the thermal flux of the fins. And what is the temperature distribution? That is degree of freedom, nodal temperature. This is what the temperature distribution, right? So we applied 1000 watts per meter as a heat flux, and applying surrounding temperature as a 293 by means of air, and coefficient between air and the that is fin and the atmosphere is 293 Kelvin. Sorry, 40 watts. So we will get the output like this. Thank you.